Originally I'm a mathematician, but I work for the ArangoDB since 2013, and so I'm one of the core developers. I hack away at C++, but I also do software architecture and the planning, what we do next and so on. And I go out to conferences and give talks and engage with the community and so on. So we are a small company. I do nearly everything. There's the details of operating systems which you have to cover. Then there's the questions how you run continuous integration. Then there's questions how you deploy to your users to produce Docker images, to produce binaries for the different machines. Then you have to support multiple C++ compilers. You have to get the documentation right. You have to have enough documentation, but you also need to have short documentation for people to get started. And maybe the most difficult one is you have to find a balance between a complicated, powerful product and one that is easy and fun to use. You have to get the balance right. Well, the data which is collected is growing ever more. The access to storage and computers we have and cloud computing is growing. So therefore, people want to use this data. And so therefore, they not only need data stores to keep them, but also data stores to query them and analytics engines, and they want to draw value out of their data. And so therefore, there's an ever-growing demand for data stores and query engines and data processing machinery. Because for different purposes, you need different types of data models. For a shopping basket, you need a key value store. Sometimes you need something where you can run joins. Sometimes you need a relational store, or for other purposes, you need a graph database. And so what we do with ArangoDB is we create a multi-model database where you can use the same data store for different data models and even use them in the same core, in the same query language. And my impression is that the industry is moving towards more flexibility with respect to data models and towards the integration of different data models into single stores. You will still have different things. You will still have time series and columnar store as well. But what we attack is we attack documents, graphs, and key value in one engine with a single query language. And I'm observing that a lot of the industry is moving towards that greater flexibility in one product. Open source has become very, very popular, and people understand the value. It's not that it's for free, but it is, you can look into it, you can contribute, you can fix things, and even if a company goes bust, the source code is still there, and one can, in principle, hire developers to move on with it. So it's essentially just a safety net. But I think also that big companies and small companies alike have noticed that the open source idea improves quality. And therefore, fortunately, in this NoSQL market, apart from the big relational databases, most players actually are open source, or at least, like in our case, have a community open source edition and then maybe an enterprise edition, because after all, a company looking after such a data store has to make money somehow. To be honest, we need both. Our query language supports a certain number of possibilities for analytics in the data store, because if you can do it with simple methods, we want to do it directly on your data. But these days, a data store cannot stay separate. You need integration with other systems. So for example, ArangoDB you can deploy within an Apache Mesos cluster, and it's very, very easy to deploy other things like Spark or Hadoop in the same cluster and share resources. And that is very, very important these days, that you have connections and interoperability such that you can do whatever is best. If you can do a quick query in the database, fine. If you need a batching or stronger analytics engine, you want to have no friction to move your data out to Spark, do the analysis there. Or if you have some graph sitting in your Hadoop cluster, you want to be able to quickly import it to ArangoDB and do ad hoc queries. And this kind of interoperability becomes more and more important. So it's both ease of deployment and then interoperability with other systems. Sometimes this is very useful. If you take, for example, graph databases, it is extremely useful to quickly look at a graph in the vicinity of a vertex to see what's going on, how the graph is structured, how long the paths are, and so on. So this is, I think, an important aspect. But then, if you have very high dimensional data, you just can't imagine it and you can't display it nicely. Or if you have a graph with 1,000,000 vertices and every vertex has 100 edges, then you can't see it anymore. So therefore you need sophisticated visualization tools, and yet sometimes it doesn't work, so you need to go other routes as well.